Now, let us move on to some applications of vector algebra to geometry and mechanics. Work done by a force. We know that force F is a vector and dot D, where D is the displacement, gives us the work done by the force F along the displacement Now, this is very important, this language, along the displacement. This means that we are to calculate the displacement through the direction the F is acting. Let us assume that this is a point A and this is a point B, and we displace a particle from A to B. Then D will be AB, and the vector AB will be calculated with respect to a origin as always OB minus OA. This is very vital concept. These are the 2 points A and B. O is the origin. So, what is the position vector of A? Let us write small a. And what is the position vector of the point B? Let us write small b. So, this is OA is the position vector of the point A and OB is the position vector of the point capital B. Small b is the position vector of the point capital B. So, from the triangle law we see that OA plus AB, OA plus AB is equal to OB. So, AB will turn out to be OB minus OA, and this gives us the displacement as B minus A, isn't it so? So, this is AB, always remember this. The AB vector has direction. So, if F, the force, takes the particle from A to B, the work done will be F dot D. The direction is not that much important here because the work done is a scalar quantity, but in case of moment this would be very pertinent and very important. Let us see what happens in case of a moment of a force about a point. We must remember that moment of a force about a point, this is a force F and this is a point say P with radius vector say R. So, what is the moment of F about this point? We will have to take a point Q here and we will have to find out this vector PQ, and whenever we found the vector PQ, the moment of F about P will turn out to be R cross, sorry, R is written as the position vector of P. So, we should not write R, we should write PQ cross F. This is called the arm of the moment, and if we represent this as R, then this is called R cross F. This R and this R is not the same, do not confuse. I should not write R here. Let us put R prime, which is the position vector of P, and we know that if this is origin and this is R prime and this Q point is known having radius vector R double prime say, then PQ will be found out from the triangle law, OP plus PQ equal to OQ. So let us put that to be R. Then R cross F is the moment of F about P. So this much about the application to physics. Now there is application to geometry. Two very small things I will discuss. One is the equation of straight line and another is equation of plane. What is the equation of straight line? This is written as this, A plus TB, where T is any scalar. Now this statement is more or less vague. We must explain. Let us assume that this is the straight line AB. These 2 points are fixed, having position vector A and B. Here also we have a origin here, with respect to which OA and OB are given. OA is the small vector A and OB is the small vector B. Now we try to find the equation of this straight line. So we will have to fix up a point P, which is the locus point of this straight line. We know the idea of the locus point. This point P draws the straight line. And we know from geometry that whenever 2 fixed points are given, there is one and only one straight line through these 2 fixed points. And we can easily see that AP is a part of AB. If P is outside AB, then also AP is a part of AB. So we can easily write AP equal to some scalar lambda into AB. And since AP is R minus A, just see that AP is R minus A. This you should always remember in terms of the position vector. And what will be AB? AB will be B minus A. And with a slight adjustment, this will turn out to be this. And this is the equation of a straight line through 2 fixed points given as capital A and capital B, having position vector small a and small b. When you know these 2 fixed points, you know the equation of the straight line. And this is vector form. You can easily reduce it to your known form as in geometry. See, R is x I cap plus y j cap, we know, and A is A1 I cap, A2 j cap, and B is B1 I cap and B2 j cap. So if we equate them, then what is x? X is A1 plus TB1, and y, what is y? A2 plus TB2. From these two, we can easily equate the value of t as x minus A1 by B1, and from here we have y minus A2 by B2. You can easily identify this as a, just have a look. X minus A1 by B1 is equal to y minus A2 by B2. This is the known equation of straight line in geometry. So R equal to A plus TB is the form of vector form of a straight line. Now let us move on to the equation of plane. Vector equation of a plane may be written as R dot n cap equal to P. This is an application of vector. You know that the equation of plane may be written as Lx plus My plus Nz equal to P, where L, M and N are the direction cosines of the straight line which is perpendicular to the plane, whose equation is this. Now we also know that if we have two intersecting straight lines, then we have a fixed plane. through these two intersecting straight lines, non-collinear, three non-collinear points gives us two intersecting lines, and two intersecting lines always give us a fixed plane, such as two fixed points give us a fixed straight line. Similarly, two intersecting straight line gives us a fixed plane. So let us assume that this is the variable point P and this is two fixed points A and B. Now just see that this P has radius vector r, and you can easily find the n cap. How can you find the n cap? See, PA, what is PA? PA is A minus r. And what is PB? PB is, we can easily follow, PB is B minus r. Always remember this, a straight line representing a vector with two endpoints P and B having position vector r cap, r vector and B vector is represented by B minus r. So if we take the cross product of these two, we get the perpendicular vector n cap on this plane. Now the r is the position vector of this, so r dot n cap will be 0, isn't it so? So from that we arrive to this equation. We can easily follow. We just take cross product of these two vectors, and then take dot product with any other vector of this plane. Since they are perpendicular, their dot product will be 0, and from that we can arrive at this form. And these two are equivalent. Why? Because r vector is represented by xi cap, yj cap and zk cap. Our n cap vector is represented by li cap, mj cap and n cap. When I take dot product, it becomes lx plus my plus nz, and p is the perpendicular distance from origin upon the plane. We know that. So just remember this to be the vector equation of the plane having n cap as the unit normal on that